Hey class, it's Mrs. Lowe here. We're working in Chapter 6, Analyzing Quadratic Functions, and today we're going to be sketching a quadratic function without a graphic display calculator. So the function we're going to graph is actually from your textbook. It's on page 297, number 2C. Though you didn't have to graph it according to the homework, we're going to do one as a sample, which is something you can expect to see on the assessment. So the first thing you might notice is that the leading coefficient is negative. So that tells us right there that the quadratic is going to open downward, and that will be good information for when we go to graph it. So I'm going to need several points, preferably 5 points, and I'm going to start with trying to find the X intercepts, and I'm going to do that by factoring. So I'm going to let y equal to 0. I'm going to factor out the GCF, which is the leading coefficient of negative 3x, which is going to switch the signs of all three of those terms when I factor that out. So far I factored out a GCF, and now I'm going to factor the trinomial. The middle term will split to negative 4x, negative 2x. I will pull out a GCF of x minus 4, bring down the minus, pull out a GCF of 2, x, that should be a plus, x minus 4, it should be parentheses, and bracket here. So it factors to negative 3, x minus 4, x minus 2, and this is all equal to 0. This is all that we've learned in Chapter 5. So now I'm going to set each factor equal to 0. Negative 3 doesn't have a variable, so we can throw it away. And x is 4 and x is 2 for the X intercepts. The next thing I'm going to do is find the vertex. And I find the vertex first by finding the x-coordinate of the vertex. The x-coordinate of the vertex is the average of the x-coordinates of the intercepts, or any symmetrical points. You can find the x-coordinate of the vertex. So halfway between 4 and 2, you should realize is 3. But if you're not, we'll do the x-coordinate of the vertex algebraically. It's the average of the two, and indeed it is 3. Now I have to find the y-coordinate of the vertex because I only have half the point, so I'm going to plug the 3 into the function. Negative 3 times 3 squared plus 18 times 3 minus 24. And even though you're not allowed to use a graphic display calculator, you can use a handheld, which will certainly help you with the algebra portions of these problems, and you get y is 3. So the vertex is 3, 3. So far we have 4 points. The next thing I'm going to do is find the y-intercept, or I could find any additional point, but I'm going to find the y-intercept because it's so easy to find, because all you do is you make x equal to 0. So I'm plugging in 0 into the original function up at the top, and you basically get negative 24. So we have another point, which is 0, negative 24. Now we're going to find its symmetrical point. Well, its symmetrical point will have the same height, which is negative 24. So the same y value of negative 24. So I'm going to find the y-intercepts symmetrical point. And that's with the same y value. So again, we're going to use the original function. I'm going to make the y value negative 24, and I have negative 3x squared plus 18x minus 24. And I'm going to solve for x. I already know one of the values of x is equal to 3. I will add 24 to both sides, and I'll be left with negative 3x squared plus 18x. I will factor out the GCF, which is negative 3x. And excuse me, we already know one of the x values is 0 because we've already found that with the y-intercept. So we have x plus 6 here. When you set each factor equal to 0, you get x is 0. We already knew that because This is the y-intercept, which we got here, and the other x value that goes with negative 24 for y is negative 6. So the mirror or symmetrical point for the y-intercept is negative 6, negative 24. So you have 5 points now, and you can graph the function using those 5 points. Graph the function using those 5 points. So I'll just do a little sketch of it over here. We know that the graph opens downward. We know it's going to go downward. We know the x-intercept is 2, 3, 4, 2 and 4. We know the y-intercept, or excuse me, the vertex is 3, 3. This is not necessarily to scale. We know that the y-intercept is 0, negative 24. We'll say that's negative 24. And we know the symmetrical point is 6, negative 24 down there. So not exactly to scale, but you get an idea. And there is the graph of that quadratic function. Hopefully that helps. I know this is a little bit longer than most, but this is a long problem and one you'll be seeing on the assessment.